The main objective of this presentation is to establish validity of the idea. Many thanks to all those who provide constructive criticism. Link to the PDF version of this presentation is in the description. I try never to forget that extraordinary claims require extraordinary evidence. The main piece of experimental evidence I'm aware of supporting virtual particles being real is the dynamic Casimir effect. The result being real microwaves, not charged particles though. You can find many papers starting with Dirac, de Broglie, and many others that support the idea of the vacuum consisting of virtual particles. The papers below mainly talk about zero-point energy and gravity. My focus is on basically virtual particles popping in and out of existence and interacting with the magnetic field. There are some questions that I have. For example, do virtual particles interact with magnetic fields? Obviously, let's assume that they do. What is the v, which I call it pop-up velocity in quantum form? Is it Planck's length over uncertainty delta t? What is the particle density at the given moment? I mean, particle density of those particles that pop in and out, and are Maxwell's equations applicable? Here's the thought experiment. We have a magnetic field whose strength is not uniform, it's just increasing from here to here. And we have a plus minus pop out and minus plus pop out. And you would have trajectories of plus minus pop out and minus plus pop out, as I call them. And since the magnetic field strength is increasing in this direction, this radius of this curve is smaller than the radius of this curve. Consequently, the Fa is higher than Fb, and the resulting reaction force is pointing downwards. So this is basically main idea. Another idea is, assuming that this is the case and we have a force pointing downwards, would spinning the setup in a way like a sort of like a propeller, would that enhance the effect? Unfortunately, I do not have time to dive in and then come up with the full mathematical equations. I'll do that when I retire. Moreover, there are some measurements that I'm not aware that have been performed that I would need for my mathematical analysis. So I'll try to basically set up an experiment and see if I can have some results. Another problem is that I don't have a lab that is shielded from the Earth's magnetic field. So I decided to come up with something with experiments that basically cancel the influence of Earth's magnetic field. So here we are. So we have basically standard neodymium magnets, and we have the sort of a picture how they are affected by Earth's magnetic field. Here is the compass needle at my location, basically some measurements of my setup. Let's see the results. Here we have what I call positive bias setups. These are setups in which the force that you're looking for, its direction, is the same as in direction of the force that results with the interaction of this small magnet with the Earth's magnetic field. So whether this force exists or not, you would have a positive result. Here is the same. So there's no point in testing in these configurations. Here we have what I call negative bias setups. In these setups, you may have negative results, but still the force may exist. But if the QF is stronger than Fe2, which is basically resulting from the interaction of this magnet with the Earth's magnetic field, then you would see positive results. So in this case, I would see that if you measure the H in this configuration, which is a push configuration, which the magnets repel each other, minus the pull configuration where the magnets attract each other, and if the H push is higher than H pull, then the result is positive. In this case, it's the opposite. However, I find this case is more prone to errors because these forces should cancel out. However, the contribution of these forces is way higher, because if you flip these guys, the arm is longer. So, and that's what I think it's shown in the results. Most of them are positive. There are some negatives, and these negatives are the result of basically cheaper setups, or the equipment that I have. We need to be, you know, more expensive and more finely tuned, or not, or maybe there is something else. So that's what I'd like to know, and I will continue testing. Thank you very much, and I hope I have not wasted your time.